The Amiga is a family of personal computers sold by Commodore in the 1980s and 1990s. The first model was launched in 1985 as a high-end home computer and became popular for its graphical, audio and multitasking abilities. The Amiga provided a significant upgrade from 8-bit computers, such as the Commodore 64, and the platform quickly grew in popularity among computer enthusiasts. The name Amiga was chosen because it is the Spanish word for friend, and alphabetically it appears before Apple in lists of computer makers. It originated as a project called Lorraine, therefore the female was used instead of the male and general version Amigo. The best-selling model, the Amiga 500, was introduced in 1987 and became the leading home computer of the late 1980s and early 1990s in much of Western Europe. In North America, success was more modest. The Amiga went on to sell approximately 6 million units. As the second generation of Amiga systems, the A1200 and the A4000 were released in 1992. However, poor marketing and failure to repeat the technological advances of the first systems meant that the Amiga quickly lost its market share to competing platforms, such as the fourth-generation game consoles, Apple Macintosh and IBM PC compatibles. Based on the Motorola 68000 family of microprocessors, the machine has a custom chipset with graphics and sound capabilities that were unprecedented for the price, and a preemptive multitasking operating system called Amiga Os. The original operating system, partly based on Tripos and written in BCPL, was called Amiga DOS and the GUI was called Workbench. When it was eventually renamed Amiga Os, the BCPL parts were rewritten in C language. Although early Commodore advertisements attempted to cast the computer as an all-purpose business machine, the Amiga was most commercially successful as a home computer, with a wide range of games and creative software. It was also a less expensive alternative to the Apple Macintosh and IBM PC as a general-purpose business or home computer. Initially, the Amiga was developed alongside various PC-compatible systems by Commodore, but later Commodore left the PC market. The platform became particularly popular for gaming and programming demos. It also found a prominent role in the desktop video production, and show control business, leading to affordable video editing systems such as the Video Toaster. The Amiga's native ability to simultaneously play back multiple digital sound samples made it a popular platform for early tracker music software. The relatively powerful processor and ability to access several megabytes of memory led to the development of several 3D rendering packages, including Lightwave 3D and Aladdin 4D. Since the demise of Commodore, various groups have marketed successors to the original Amiga line, including Genesee, iTech, Cube Systems and Aeon Technology. Likewise, Amiga OS has influenced replacements, clones and compatible systems such as MorphOS, Amiga OS 4 and AROS. The demise of Commodore has been commonly attributed to numerous factors such as poor marketing, a lack of sufficient third-party developers, and a failure to compete with cheaper PC clones with multimedia features and low-cost color-capable Macintosh models such as the Macintosh LC. History. The Amiga was so far ahead of its time that almost nobody including Commodore's marketing department could fully articulate what it was all about. Today, it's obvious the Amiga was the first multimedia computer, but in those days it was derided as a game machine because few people grasped the importance of advanced graphics, sound, and video. 9 years later, vendors are still struggling to make systems that work like 1985 Amigas. Development of the Amiga began in 1982 with J. Miner, developer of the Atari 800 chipset, as the principal hardware designer of Amiga Corporation. It was initially intended to be a next-generation video game machine, but was redesigned as a general-purpose computer after the North American video game crash of 1983. A prototype of the full computer was shown to the public for the first time at the Summer Consumer Electronics Show in 1984. In order to bring the design to market, Commodore International bought Amiga Corporation and funded development. The first model was released in 1985 as simply the Amiga from Commodore, later to be retroactively dubbed the Amiga 1000. The following year the Amiga product line was expanded with the introduction of two new models, the Amiga 2000 for high-end graphics and business use, and the Amiga 500 for home use. Commodore later released other Amiga models, both for low-end gaming use and high-end productivity use. In 1994, Commodore filed for bankruptcy and its assets were purchased by ESCOM, a German PC manufacturer, who created the subsidiary company Amiga Technologies. They re-released the A1200 and A4000T, and introduced a new 68060 version of the A4000T. However, ESCOM in turn went bankrupt in 1997. The Amiga brand was then sold to another PC manufacturer, Gateway 2000, which had announced grand plans for it. However, in 2000, Gateway sold the Amiga brand without having released any products. The current owner of the trademark, Amiga, Incorporated, licensed the rights to sell hardware using the Amiga or Amiga One brand to computer vendors Commodore USA, iTech Group, Limited and Aeon Technology CVBA. Unofficial Amiga One clones were developed by Italian hardware company, The Cube Hardware. At its core, the Amiga has a custom chipset consisting of several coprocessors, which handle audio, video and direct memory access independently of the central processing unit. This architecture freed up the Amiga's processor for other tasks and gave the Amiga a performance edge over its competitors, particularly in terms of video-intensive applications and games. The general Amiga architecture uses two distinct bus subsystems, namely, the chipset bus and the CPU bus. The chipset bus allows the custom coprocessors and CPU to address chip RAM. The CPU bus provides addressing to other subsystems, such as conventional RAM, ROM and the Zorro 2 or Zorro 3 expansion subsystems. This architecture enables independent operation of the subsystems. The CPU fast bus can be much faster than the chipset bus. CPU expansion boards may provide additional custom buses. Additionally, busboards, or bridge boards may provide ISA or PCI buses. Central Processing Unit, the Motorola 68000 series of microprocessors was used in all Amiga models from Commodore. While the 68000 family has a 32-bit design, the 68000 used in several early models is generally referred to as 16-bit. The 68000 has a 16-bit external data bus so must transfer 32 bits of data in two consecutive steps, a technique called multiplexing. All this is transparent to the software, which was 32-bit from the beginning. The 68000 could address 16 megabytes of physical memory. Later Amiga models featured full 32-bit CPUs with a larger address space and instruction pipeline facilities. Commodore's design choice to remain with the 68000 architecture ensured that code was backward compatible across the Amiga line. CPU upgrades were offered by both Commodore and third-party manufacturers. Most Amiga models can be upgraded either by direct CPU replacement or through expansion boards. Such boards often featured faster and higher capacity memory interfaces and hard disk controllers. Towards the end of Commodore's time in charge of Amiga development there were suggestions that Commodore intended to move away from the 68000 series to higher performance RISC processors, such as the PA RISC. However, these ideas were never developed before Commodore filed for bankruptcy. Despite this, third-party manufacturers designed upgrades featuring a combination of 68000 series and PowerPC processors along with a PowerPC native microkernel and software. Later Amiga clones featured PowerPC processors only. Custom chipset. The custom chipset at the core of the Amiga design appeared in three distinct generations, with a large degree of backward compatibility. The original chipset appeared with the launch of the A1000 in 1985. OCS was eventually followed by the modestly improved enhanced chipset in 1990 and finally by the partly 32-bit advanced graphics architecture in 1992. Each chipset consists of several coprocessors which handle graphics acceleration, digital audio, direct memory access and communication between various peripherals. In addition, some models featured auxiliary custom chips which performed tasks such as SCSI control and display deinterlacing. Graphics. All Amiga systems can display full-screen animated graphics with 2, 4, 8, 16, 32, 64 or 4096 colors. Models with the AGA chipset also have non-EHB64, 128, 256 and 262,144 color modes and a palette expanded from 4096 to 16.8 million colors. The Amiga chipset can gen-lock, which is the ability to adjust its own screen refresh timing to match an NTSC or PAL video signal. When combined with setting transparency, this allows an Amiga to overlay an external video source with graphics. This ability made the Amiga popular for many applications, and provides the ability to do character generation and CGI effects far more cheaply than earlier systems. This ability has been frequently utilized by wedding videographers, TV stations and their weather forecasting divisions, advertising channels, music video production, and desktop videographers. The NewTek video toaster was made possible by the gen-lock ability of the Amiga. In 1988, the release of the Amiga A2024 fixed-frequency monochrome monitor with built-in frame buffer and flicker fixer hardware provided the Amiga with a choice of high-resolution graphic modes. Retargetable graphics. Retargetable graphics is an API for device drivers mainly used by third-party graphics hardware to interface with Amiga OS via a set of libraries. The software libraries may include software tools to adjust resolution, screen colors, pointers and screen modes. It uses available hardware and does not extend the capabilities in any way. Amiga Intuition library is limited to display depths of 8 bits, but ATG libraries makes it possible to handle higher depths like 24 bits. Sound. The sound chip, named Paula, supports 4 PCM sample-based sound channels with 8-bit resolution for each channel and a 6-bit volume control per channel. The analog outputs is connected to a low-pass filter, which filters out high-frequency aliases when the Amiga is using a lower sampling rate. The brightness of the Amiga's power LED is used to indicate the status of the Amiga's low-pass filter. The filter is active when the LED is at normal brightness, and deactivated when dimmed. On Amiga 1000, the power LED had no relation to the filter's status, and a wire needed to be manually soldered between pins on the sound chip to disable the filter. Paula can read directly from the system's RAM, using direct memory access, making sound playback without CPU intervention possible. Although the hardware is limited to 4 separate sound channels, software such as Octa-MED uses software mixing to allow 8 or more virtual channels, and it was possible for software to mix 2 hardware channels to achieve a single 14-bit resolution channel by playing with the volumes of the channels in such a way that one of the source channels contributes the most significant bits and the other the least. The quality of the Amiga's sound output, and the fact that the hardware is ubiquitous and easily addressed by software, were standout features of Amiga hardware unavailable on PC platforms for years. Third-party sound cards exist that provide DSP functions, multi-track direct-to-disc recording, multiple hardware sound channels and 16-bit and beyond resolutions. A retargetable sound API called AHI was developed allowing these cards to be used transparently by the OS and software. Kickstart Firmware. Kickstart is the firmware upon which Amiga OS is bootstrapped. Its purpose is to initialize the Amiga hardware and core components of Amiga OS and then attempt to boot from a bootable volume, such as a floppy disk or hard disk drive. Most models come equipped with Kickstart on an embedded ROM chip. Keyboard and mouse. The keyboard on Amiga computers was similar to that found on a mid-80s IBM PC, 10 function keys, a numeric keypad, and 4 separate directional arrow keys. Caps lock and control shared space to the left of A. Missing were the home, end, page up, and page down keys. These were accomplished on Amigas by pressing Shift and the appropriate arrow key. The Amiga keyboard added a help key, the lack of which made it necessary to use a function key for this purpose on PCs. In addition to the Control and Alt modifier keys, the Amiga had 2 Amiga keys, rendered as Open Amiga and Closed Amiga, similar to the open-closed Apple logo keys on Apple II keyboards. The left was used to manipulate the operating system and the right delivered commands to the application. The absence of numlock freed space for more math symbols around the number pad. Contemporary Macintosh computers, for comparison, lacked function keys completely. The mouse had two buttons like Windows, but unlike Windows, pressing and holding the right button replaced the system status line at the top of the screen with a Mac-like menu bar. As with Apple's Mac OS prior to Mac OS 8, menu options were selected by releasing the button over that option, not by left-clicking. Other peripherals and expansions. The Amiga was one of the first home computers for which inexpensive sound sampling and video digitization accessories were available. As a result of this and the Amiga's audio and video capabilities, the Amiga became a popular system for editing and producing both music and video. Many expansion boards were produced for Amiga computers to improve the performance and capability of the hardware, such as memory expansions, SCSI controllers, CPU boards, and graphics boards. Other upgrades include gen locks, network cards for Ethernet, modems, sound cards and samplers, video digitizers, extra serial ports, and IDE controllers. Additions after the demise of Commodore Company are USB cards. The most popular upgrades were memory, SCSI controllers and CPU accelerator cards. These were sometimes combined into the one device. Early CPU accelerator cards feature full 32-bit CPUs of the 68000 family, such as the Motorola 68020 and Motorola 68030, almost always with 32-bit memory and usually with FPUs and MMUs or the facility to add them. Later designs feature the Motorola 68040 or Motorola 68060. Both CPUs feature integrated FPUs and MMUs. Many CPU accelerator cards also had integrated SCSI controllers. Phase 5 designed the power-up boards featuring both a 68K and a PowerPC CPU, which are able to run the two CPUs at the same time and share the system memory. The PowerPC CPU on power-up boards is usually used as a coprocessor for heavy computations. A powerful CPU is needed to run MAME, for example, but even decoding JPEG pictures and MP3 audio was considered heavy computation at the time. It is also possible to ignore the 68K CPU and run Linux on the PPC via Project Linux APUS, but a PowerPC native Amiga OS promised by Amiga Technologies GmbH was not available when the power-up boards first appeared. 24-bit graphics cards and video cards were also available. Graphics cards are designed primarily for 2D artwork production, workstation use, and later, gaming. Video cards are designed for inputting and outputting video signals, and processing and manipulating video. Perhaps the most famous video card in the North American market was the NewTek Video Toaster. This was a powerful video effects board which turned the Amiga into an affordable video processing computer which found its way into many professional video environments. One particularly well-known use was to create the special effects in early series of Babylon 5. Due to its NTSC-only design, it did not find a market in countries that used the PAL standard, such as in Europe. In PAL countries, the Opal Vision card was popular, although less featured and supported than the Video Toaster. Low-cost time-bus correctors specifically designed to work with the toaster quickly came to market, most of which were designed as standard Amiga bus cards. Various manufacturers started producing PCI busbuds for the A1200 and A4000, allowing standard Amiga computers to use PCI cards such as Voodoo graphic cards, Sound Blaster sound cards, 10/100 Ethernet cards, and TV tuner cards. Other manufacturers produced hybrid boards which contained an Intel x86 series chip, allowing the Amiga to emulate a PC. PowerPC upgrades with wide SCSI controllers, PCI busbuds with Ethernet, sound and 3D graphics cards, and tower cases allowed the A1200 and A4000 to survive well into the late 90s. Expansion boards were made by Richmond Sound Design that allow their show control and sound design software to communicate with their custom hardware frames either by ribbon cable or fiber optic cable for long distances, allowing the Amiga to control up to 8 million digitally controlled external audio, lighting, automation, relay and voltage control channels spread around a large theme park, for example. See Amiga Software for more information on these applications. Other popular devices included the following: Amiga 501 with 512 KB RAM and a real-time clock. Trump Card 500 Zorro IISCSI interface. GVPA 530 Turbo, accelerator, RAM expansion, PC emulator. A2091 Peripherals 590 SCSI hard disk controller plus 2 MB RAM expansion. A3070 SCSI tape backup unit with a capacity of 250 MB, OEM archive Viper 1/4. A2065 Ethernet Zorro AI interface. The first Ethernet interface for Amiga. Uses the AMD M7990 chip. The same interface chip is used in DECstation as well. Ariadne Zorro II Ethernet interface using the AMD M7990. A4066 Zorro II Ethernet interface using the SMC91C90QF. XSUR from individual computers using the Realtek 8019AS. A2060 ArcNet. A1010 floppy disk drive. Consists of a 3.5-inch double-density, 300 RPMs, 250 KB ITS drive unit connected via DB23 connector. Track-to-track delay is on the order of 94 milliseconds. The default capacity is 880 kilobytes. Many clone drives were available, and products such as the Catweasel make it possible to read and write Amiga and other special disk formats on standard x86 PCs. Nebraska, 2000 compatible PCMCIA Ethernet cards for Amiga 600 and Amiga 1200, serial ports. The Commodore A2232 provides 7 RS-232C serial ports. Each port can be driven independently at speeds of 50-19 200-bit s. There is however a driver available on a minute that allows 2 of the serial ports to be driven at 115 200-bit s. The serial card made use of the 65CE02 CPU clocked at 3.58 MHz. This CPU are also part of the CSG4510 CPU core that were used in the Commodore 65 computer. Networking. Amiga has 3 networking interface APIs, AS225, the official Commodore TCP/IP stack API with hard-coded drivers and revision 1 for the A2065 Ethernet and the A2060 ArcNet interfaces. In revision 2 the SAN-AII interface was used. SAN-AII, a standardized API for hardware of network interfaces. It uses an inefficient buffer handling scheme, and lacks proper support for promiscuous and multicast modes. Miami Network Interface, an API that doesn't have the problems which SAN-AII suffers from. It requires Amiga OS v2, 04 or higher. Different network media were used, models and variants. The original Amiga models were produced from 1985 to 1996. They are, in order of appearance, 1000, 2000, 500, 1500, 2500, 3000, 3000 UX, 3000T, CDTV, 500 plus, 600, 4000, 1200, CD32, and 4000T. The PowerPC-based Amiga 1 was later produced from 2002 to 2005, and again in 2012. Several companies and private persons have also released Amiga clones and still do so today. Commodore Amiga. The first Amiga model, the Amiga 1000, was launched in 1985 as a high-end home computer and became popular for its impressive graphics, video and audio capabilities. In 2006, PC World rated the Amiga 1000 as the 7th greatest PC of all time, stating years ahead of its time, the Amiga was the world's first multimedia, multitasking personal computer. Following the A1000, Commodore updated the desktop line of Amiga computers with the Amiga 2000 in 1987, the Amiga 3000 in 1990, and the Amiga 4000 in 1992, each offering improved capabilities and expansion options. However, The best-selling models were the budget models, particularly the highly successful Amiga 500 and the Amiga 1200. The Amiga 500 Plus was the shortest-lived model, replacing the Amiga 500 and lasting only 6 months until it was phased out and replaced with the Amiga 600, which in turn was also quickly replaced by the Amiga 1200. The CD-TV, launched in 1991, was a CD-ROM-based all-in-one multimedia system. It was an early attempt at a multi-purpose multimedia appliance in an era before multimedia consoles and CD-ROM drives were common. Unfortunately for Commodore, the system never achieved any real commercial success. Like the Commodore 64 GS that was a video game console based on a computer, the CD-TV was designed as a video game console, a multimedia platform. It had existed before the Sony PlayStation and Sega Saturn, but had influenced them. It competed with the TurboGrafx 16 CD and Sega Mega CD systems when it was being sold. Commodore's last Amiga offering before filing for bankruptcy was an attempt to capture a portion of the highly competitive 1990s console market with the Amiga CD32, a 32-bit CD-ROM games console. Though discontinued after Commodore's demise, it met with moderate commercial success in Europe. The CD32 was a next-generation CD-TV, and it was designed to save Commodore by entering the growing video game console market. Following purchase of Commodore's assets by ESCOM in 1995, the A1200 and A4000T continued to be sold in small quantities until 1996, though the ground lost since the initial launch and the prohibitive expense of these units meant that the Amiga line never regained any real popularity. Several Amiga models contained references to songs by the rock band the B-52s. Early A500 units, at least, had the words B-52/Rock Lobster silkscreen printed onto their printed circuit board, a reference to the popular song Rock Lobster. The Amiga 600 referenced June Bug, and the Amiga 1200 had Channel Z. Most original casing was made from ABS plastics which may become brown with time. This can be reversed by using the public domain chemical mixer ETRO Bright. Amiga OS 4 systems. Amiga OS 4 is designed for PowerPC Amiga systems. It is mainly based on Amiga OS 3.1 source code, with some parts of version 3.9. Currently runs on both Amigas equipped with CYBERSTORM PPC or Blizzard PPC accelerated boards, on the Terran series-based Amiga 1 computers built by iTech under license by Amiga Incorporated, on the Pegasus 2 from genus B-Plan GmbH, on the Acube system SAM 440EP/SAM 460X/Amiga 1500 systems and on the Aeon Amiga 1X1000. Amiga OS 4.0 had been available only in developer pre-releases for numerous years until it was officially released in December 2006. Due to the nature of some provisions of the contract between Amiga Incorporated and Hyperion Entertainment, the commercial Amiga OS 4 had been available only to licensed buyers of Amiga 1 motherboards. Amiga OS 4.0 for Amigas equipped with power-up accelerated boards was released in November 2007. Version 4.1 was released in August 2008 for Amiga 1 systems, and in May 2011 for Amigas equipped with power-up accelerated boards. The most recent release of Amiga OS for all supported platforms is 4.1 Update 5. Starting with release 4.1 Update 4, there is an emulation drawer containing official Amiga OS 3X ROMs and relative workbench files. Acube Systems entered an agreement with Hyperion under which it has ported Amiga OS 4 to its SAM 440EP and SAM 460X line of PowerPC-based motherboards. In 2009, a version for Pegasus 2 from genus B-Plan GmbH was released in cooperation with Acube Systems. In 2012, Aeon Technology Limited manufactured and released the Amiga 1X1000 to consumers through their distributor, AmigaKit.com. Amiga Hardware Clones. Longtime Amiga developer Macrosystem entered the Amiga clone market with their Draco nonlinear video editing system. It appears in two versions, initially a tower model and later a cube. Draco expanded upon and combined a number of earlier expansion cards developed for Amiga into a true Amiga clone powered by the Motorola 68060 processor. the Draco can run Amiga OS 3.1 up through Amiga OS 3.9. It is the only Amiga-based system to support FireWire for video I/O. Draco also offers an Amiga-compatible Zorro AI expansion bus and introduced a faster custom Draco bus, capable of 30 megabytes per second transfer rates. The technology was later used in the Casablanca system, a set-top box also designed for non-linear video editing. In 1998, Index Information released the Access, an Amiga clone similar to the Amiga 1200, but on a motherboard which could fit into a standard 5 1/4 drive bay. It features either a 68020 or 68030 CPU, with a redesigned AGA chipset, and runs Amiga OS 3.1. In 1998, former Amiga employees formed a new company called PIOS. Their hardware platform, PIOS-1, was aimed at Amiga, Atari and Macintosh users. The company was renamed to Metatbox in 1999 until it folded. The NetAmi hardware project began in 2005 with the aim of designing and building an Amiga clone motherboard that is enhanced with modern features. The NetAmi motherboard is a standard mini-ITX-compatible form-factor computer motherboard, powered by a Motorola Freescale 68060 and its chipset. It is compatible with the original Amiga chipset, which has been inscribed on a programmable FPGA Ultra chip on the board. The NetAmi is the second Amiga clone project after the Minimig motherboard, and its history is very similar to that of the C1 mainboard developed by Jerry Ellsworth and Jens Paragraph NFELD. From a commercial point of view, NetAmi's circuitry and design are currently closed source. One goal of the NetAmi project is to design an Amiga-compatible motherboard that includes up-to-date features but that does not rely on emulation, modern PC Intel components, or a modern PowerPC mainboard. As such, NetAmi is not intended to become another evolutionary heir to classic Amigas, such as with Amiga 1 or Pegasus computers. This purist philosophy essentially limits the resulting processor speed but puts the focus on bandwidth and low latencies. The developers also recreated the entire Amiga chipset, freeing it from legacy Amiga limitations such as 2 MB of audio and video graphics RAM as in the AGA chipset, and rebuilt this new chipset by programming a modern FPGA Ultra Cyclone 4 chip. Later, the developers decided to create from scratch a new software form processor chip, codenamed N68050 that resides in the physical Ultra FPGA programmable chip. In 2006, 2 new Amiga clones were announced, both using FPGA-based hardware synthesis to replace the Amiga Os CS custom chipset. The first, the Minimig, is a personal project of Dutch engineer Dennis van Weeren. Referred to as new Amiga hardware, the original model was built on a Xilinx Spartan 3 development board, but soon a dedicated board was developed. The Minimig uses the FPGA to reproduce the custom Denise, Agnes, Paula and Gary chips as well as both 8520 CIAs and implements a simple version of Amber. The rest of the chips are an actual 68000 CPU, RAM chips, and a PIC microcontroller for BIOS control. The design for Minimig was released as open source on July 25, 2007. In February 2008, an Italian company Acube Systems began selling Minimig boards. A third-party upgrade replaces the PIC microcontroller with a more powerful ARM processor, providing more functionality such as write access and support for hard disk images. The Minimig core has been ported to the FPGA Arcade Replay board. The Replay uses an FPGA with about 3 times more capacity and which does support the AGA chipset and a 68020 soft core with 68030 capabilities. The Replay board is designed to implement many older computers and classic arcade machines. The second is the Clone A system announced by Individual Computers. As of mid-2007 it has been shown in its development form, with FPGA-based boards replacing the Amiga chipset and mounted on an Amiga 500 motherboard. In 2011 by Arcade Retro Gaming, called the Multiple Classic Computer, which emulates the Commodore 64. Support for Amiga software is planned. Emulation. Like many popular but discontinued platforms, the Amiga has been the target of various emulation projects so that software developed for the Amiga can be run on other computer platforms without the original hardware. Such emulators attempt to replicate the functionality of the Amiga architecture in software. As mentioned above, attempts have also been made to replicate the Amiga chipset in FPGA chips. One of the most challenging aspects of emulation is the design of the Amiga chipset, which relies on cycle-critical timings. As a result, early emulators did not always achieve the intended results, though later emulator versions can now accurately reproduce the behavior of Amiga systems. Operating systems, Amiga Os. Amiga Os remains one of the great operating systems of the past 20 years, incorporating a small kernel and tremendous multitasking capabilities, the likes of which have only recently been developed in OS/2 and Windows NT. The biggest difference is that the Amiga Os could operate fully and multitask in as little as 250K of address space. Amiga Os is a single-user multitasking operating system. It was developed first by Commodore International, and initially introduced in 1985 with the Amiga 1000. Original versions run on the Motorola 68000 series of microprocessors, while Amiga OS 4 runs only on PowerPC microprocessors. At the time of release, Amiga OS put an operating system that was well ahead of its time into the hands of the average consumer. It was one of the first commercially available consumer operating systems for personal computers to implement preemptive multitasking. Another notable feature was the combined use of both a command line interface and graphical user interface. Amiga DOS was the disk operating system and command line portion of the OS, and Workbench the native graphical windowing, icons, menu and pointer environment for file management and launching applications. Notably, Amiga DOS allowed long file names with whitespace and did not require file extensions. The windowing system and user interface engine which handles all input events is called Intuition. The multitasking kernel is called EXIC. It acts as a scheduler for tasks running on the system, providing preemptive multitasking with prioritized round-robin scheduling. It enabled true preemptive multitasking in as little as 256 kilobytes of free memory. Amiga OS is one of the few microkernel-based operating systems not to implement memory protection, though this lack is common amongst many of its contemporary operating systems. The lack of memory protection is because the 68000 CPU does not include a memory management unit, and therefore there is no way to enforce protection of memory. Although this speeds and eases inter-process communication because programs can communicate by simply passing a pointer back and forth, the lack of memory protection made the Amiga OS more vulnerable to crashes from badly behaving programs than other multitasking systems that did implement memory protection, and Amiga OS is fundamentally incapable of enforcing any form of security model since any program had full access to the system. A co-operational memory protection feature was implemented in Amiga OS 4 and could be retrofitted to old Amiga OS systems using Enforcer or CyberGuard tools. The problem was somewhat exacerbated by Commodore's initial decision to release documentation relating not only to the OS's underlying software routines, but also to the hardware itself, enabling intrepid programmers who had developed their skills on the Commodore 64 to poke the hardware directly, as was done on the older platform. While the decision to release the documentation was a popular one and allowed the creation of fast, sophisticated sound and graphics routines in games and demos, it also contributed to system instability as some programmers lacked the expertise to program at this level. For this reason, when the new AGA chipset was released, Commodore declined to release low-level documentation in an attempt to force developers into using the approved software routines. Influence on other operating systems, Amiga OS directly or indirectly inspired the development of various operating systems. MorphOS and AROS clearly inherit heavily from the structure of Amiga OS as explained directly in articles regarding these two operating systems. Amiga OS also influenced BOS, which featured a centralized system of data types, similar to that present in Amiga OS. Likewise, Dragonfly BSD was also inspired by Amiga Os as stated by Dragonfly developer Matthew Dillon, who is a former Amiga developer. Window Lab and Amima are among several window managers for the X Window system seek to mimic the Workbench interface. IBM licensed the Amiga GUI from Commodore in exchange for the REXX language license. This allowed OS/2 to have the WPS GUI shell for OS/2 2.0, a 32-bit operating system. Unix and Unix-like systems. Commodore Amiga produced Amiga Unix, informally known as Amix, based on AT&T SVR4. It supports the Amiga 2500 and Amiga 3000 and is included with the Amiga 3000 UX. Among other unusual features of Amix is a hardware-accelerated windowing system which can scroll windows without copying data. Amix is not supported on the later Amiga systems based on 68040 or 68060 processors. Other, still maintained, operating systems are available for the classic Amiga platform, including Linux and NetBSD. Both require a CPU with MMU such as the 68020 with 68851 or full versions of the 68030, 68040 or 68060. There is also a version of Linux for Amigas with PowerPC accelerator cards. Debian and Yellow Dog Linux can run on the Amiga One. There is an official, older version of OpenBSD. The last Amiga release is 3.2. Minix 1.5.10 also runs on Amiga. Emulating other systems. The Amiga is able to emulate other computer platforms ranging from many 8-bit systems such as the Sinclair ZX Spectrum, Commodore 64, Nintendo Game Boy, Nintendo Entertainment System, Apple II and the TRS-80. The Commodore PC Transformer software emulated an IBM 5150 at 1 MHz in monochrome mode. Later PC bridge cards were a full hardware PC on a card with 808,680,386 Intel chips running MS-DOS and Windows in an Amiga window. Amax emulated an Apple Macintosh using a serial port dongle that had a Macintosh ROM on it. The Amiga had the same 68,000 CPU as the Macintosh and, using a Macintosh emulator, could run Mac 68K operating systems and programs. However, the Amiga could not directly read Macintosh 3.5 inches floppies due to their proprietary form. Further, it required a compatible Macintosh for a copy of its ROM. The Atari ST was also emulated. MAME is also available for Amiga systems with PPC accelerator card upgrades. Amiga Software. In the late 1980s and early 1990s the platform became particularly popular for gaming, demoscene activities and creative software uses. During this time commercial developers marketed a wide range of games and creative software, often developing titles simultaneously for the Atari ST due to the similar hardware architecture. Popular creative software included 3D rendering packages, bitmap graphics editors, desktop video software, software development packages and tracker music editors. Until the late 1990s the Amiga remained a popular platform for non-commercial software, often developed by enthusiasts, and much of which was freely redistributable. An online archive, Aminit, was created in 1992 and until around 1996 was the largest public archive of software, art and documents for any platform. Marketing. The name Amiga was chosen by the developers from the Spanish word for a female friend, because they knew Spanish, and because it occurred before Apple and Atari alphabetically. It also conveyed the message that the Amiga computer line was user-friendly as a pun or play on words. The first official Amiga logo was a rainbow-colored double checkmark. In later marketing material Commodore largely dropped the checkmark and used logos styled with various typefaces. Though it was never adopted as a trademark by Commodore, the boing ball has been synonymous with Amiga since its launch. It became an unofficial and enduring theme after a visually impressive animated demonstration at the 1984 Winter Consumer Electronics Show in January 1984 showing a checkered ball bouncing and rotating. Following ESCOM's purchase of Commodore in 1996, the boing ball theme was incorporated into a new logo. Early Commodore advertisements attempted to cast the computer as an all-purpose business machine, though the Amiga was most commercially successful as a home computer. Throughout the 1980s and early 1990s, Commodore primarily placed advertising in computer magazines and occasionally in national newspapers and on television. Legacy. Since the demise of Commodore, various groups have marketed successors to the original Amiga line. Genesys sold PowerPC-based hardware running Amiga OS-compatible MorphOS. iTech sold PowerPC-based hardware under the Amiga One brand from 2002 to 2005 running Amiga OS 4. Cube Systems sells the Amiga OS 3-compatible Minimig system with a Freescale MC68 SEC0100 CPU and Amiga OS 4-compatible SAM440/SAM460/Amiga One 500 systems with PowerPC processors. Aeon Technology Limited sells the Amiga OS 4-compatible Amiga One X1000 system with PA semi-proficient PA601682M processor. Amiga Kit, Amiga Store U, or Vasalia Computer sells numerous items from aftermarket components to refurbished classic systems. Amiga OS and MorphOS are commercial proprietary operative systems. Amiga OS 4, based on Amiga OS 3.1 source code with some parts of version 3.9, is developed by Hyperion Entertainment and runs on PowerPC-based hardware. MorphOS is developed by MorphOS team and is continued on Apple PowerPC-based hardware. There is also AROS, a free and open-source operative system, for Amiga 68K, x86 and ARM hardware. In particular, AROS for Amiga 68K hardware aims to create an open-source Kickstart RAM replacement for emulation purpose and/or for use on real classic hardware. Amiga Community. After Commodore went bankrupt in 1994, there remained a very active Amiga community, which continued to support the platform long after mainstream commercial vendors abandoned it. The most popular Amiga magazine, Amiga Format, continued to publish editions until 2000, some 6 years after Commodore filed for bankruptcy. Another magazine, Amiga Active, was launched in 1999 and was published until 2001. Several notable magazines are in publication today: Amiga Future, which is available in both English and German; BitPlanet, a bi-monthly magazine in Italian; and Amiga Power, a long-running French magazine. In spite of declining interest in the platform, there was a bi-weekly specialist column in the UK weekly magazine Micromart. There is also a fan website that has served as a community discussion and support resource since the 1994 bankruptcy. Other popular English-language fora also exist, particularly Amiga.org since 1994 and AmigaWorld.net and English Amiga Board. Notable historic uses: the Amiga series of computers found a place in early computer graphic design and television presentation. Below are some examples of notable users and users. Season 1 and part of Season 2 of the television series Babylon 5 were rendered in Lightwave 3D on Amigas. Other television series using Amigas for special effects included Sequest DSV and Max Headroom. In addition, many other celebrities and notable individuals have made use of the Amiga. Andy Warhol was an early user of the Amiga and appeared at the launch, where he made a computer artwork of Debbie Harry. Warhol used the Amiga to create a new style of art made with computers, and was the author of a multimedia opera called You Are the One, which consists of an animated sequence featuring images of actress Marilyn Monroe assembled in a short movie with a soundtrack. The video was discovered on 2 old Amiga floppies in a drawer in Warhol's studio and repaired in 2006 by the Detroit Museum of New Art. The pop artist has been quoted as saying, "The thing I like most about doing this kind of work on the Amiga is that it looks like my work in other media." A pioneer of the digital art movement, Lawrence Gartel, along with Jeff Bruette, personally taught Andy Warhol how to use the Amiga and relevant software. Actor Dick Van Dyke was a self-described rabid user of the Amiga, although he has since switched to other platforms and sold most of his Amiga equipment. Artist Gene Moe-Busgirold credits the Amiga he bought for his son as a bridge to learning about using paintbox programs. He uploaded some of his early experiments to the file-sharing forums on CompuServe. Tom Fulp is noted as saying he used the Amiga as his first computer for creating cartoons and animations. The Weird Al Yankovic film UHF contains a computer-animated music video parody of the Dire Straits song Money for Nothing, titled Money for Nothing Beverly Hillbillies. According to the DVD commentary track, this spoof was created on an Amiga home computer. Rolf Harris used an Amiga to digitize his hand-drawn artwork for animation on his television series, Rolf's Cartoon Club. Todd Rundgren's video Change Myself was produced with Toaster and Lightwave. An Amiga 1000 can be seen in the movie Disorderlies in the background running a heart animation. An Amiga 4000 was in Michael Jackson's movie Ghosts. At the left of the screen, an Amiga monitor and keyboard can be easily seen at the end credit. Scottish pop artist Calvin Harris composed his debut album I Created Disco with an Amiga 1200. Suzumu Hirasawa, a Japanese progressive electronic artist, is known for using Amigas to compose and perform music, aid his live shows and make his promotional videos. He has also been inspired by the Amiga, and has referenced it in his lyrics. His December 13, 1994 Adios J interactive live show was dedicated to J Minor. He also used the Amiga to create the virtual drummer Tay Nako, who was a CG-rendered figure whose performance was made with a LAN performer and was projected with DCTV. He also composed and performed Eastern Boot, the Amiga OS for boot jingle. He was an important figure in the Japanese Amiga community, and published several essays in the Amiga Forum from December 1998 to March 2002, which were republished in 2012 as the ebook Near Future Never Come, together with an interview, a model introduction, a photo glossary and Eastern Boot. He once said, "Amiga is the machine which can accept any plans of amateurs like me and make them realized. It let us easily combine what we have already done and gives us hope that I can do it. It is a machine permits even amateurs the enjoyment of computing, not operating." Electronic musician Max Tundra also created his 3 albums with an Amiga 500. A black Commodore Amiga 1200 was seen on an episode of Bones, used as evidence to lead to a murder suspect. A clip of this show hosted on YouTube became infamous because of the high number of errors in such a minor mention. Among many other errors, an IBM 5150 was shown as its floppy drive, and it was described as using a homemade operating system with a 6800 chipset. Tom Berenger's character Gary Simmons uses an Amiga 500 for his KKK network in the 1988 movie Betrayed. Most of Pokémon Gold and Silver's music was created on an Amiga computer, converted to MIDI, and then reconverted to the game's music format. Other uses: the Amiga was also used in a number of special-purpose applications. Amigas were used in various NASA laboratories to keep track of multiple low-orbiting satellites, and were still used up to 2003/2004. This is another example of long lifetime reliability of Amiga hardware, as well as professional use. Amigas were also used at Kennedy Space Center to run strip chart recorders, to format and display data, and control stations of platforms for Delta rocket launches. Mount Palomar Observatory used Amigas to calibrate and control the CCDs in their telescopes, as well as to display and store the digitized images they collected. London Transport Museum developed their own interactive multimedia software for the CD32. The software included a walkthrough of various exhibits and a virtual tour of the museum. Amiga 500 motherboards were used, in conjunction with the Laserdisc player and Genlock device, in arcade games manufactured by American Laser Games. A custom Amiga 4000T motherboard was used in the HDI 1000 medical ultrasound system built by Advanced Technology Labs. 4 Amiga 2000s were used from 1988 to 1991 to develop the digital displays panels installed in the M1A2 Abrams main battle tank built by General Dynamics Land Systems. In the General Dynamics Simulation Laboratory, the Amigas interfaced with a central simulation environment computer and produced graphics for the display panels. During demonstrations at Fort Knox, the Amigas did not interact with each other, but instead operated in remote mode, because the simulation environment computer was not portable. See also, Amiga games, Ominit, Hold and Modify, Minamig, Natami, UAE, references. External links, official Amiga OS website, history of the Amiga, famous Amiga uses, Amiga, Incorporated, Amiga hardware database, Big Book of Amiga hardware, Amiga Lorraine, finally, the next generation Atari? On the Edge, The Spectacular Rise and Fall of Commodore, the Amiga Guru book by Ralph Babel, Amiga.org, Community Forums and Support, FC Jungle Memories, Amiga Mods and MP3, Author's Cut, Amiga Crack Intro and Trainer Database, Lemon Amiga, Interactive Amiga Games Database, Print Magazine, Forum, Download Base, Article Base, Run Magazine Issue 21.